On behalf of RBCS, welcome everyone today to this webinar on fully leveraging Agile test automation. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. I'm the author of many books on software testing, as well as being a founder and past president of the ISTQB. We're continuing the recently launched experiment of having the webcam going. And let's see what you guys are seeing. Okay, there it is. I can see it. Excuse me. So you might be wondering, like, usually we see pictures of Rex and he's got a coat and tie on, so what's with the casual garb? Well, you can read that. That is the Solaris 1994 Solaris Developers Conference. So it's proving that I am indeed an old goat, not viejo. You know, as an old goat, I think I've learned a few tricks. So I'm going to try to share some of those with you about Agile automation today. If you have questions at any time throughout the webinar, just go ahead and submit them via your Q&A interface. But please remember, you'll answer them at the end. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community, because at RBCS, we are a not just for profit company. And if you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We are happy to provide a quote for any such help you might need. Contact us, info@rbcs-us.com. All right, enough for the advertisements. On with the show. So, I'm going to get my somewhat distracting picture of myself out of the way here before we get started, because I don't want to have to look at that all the whole time. So today we're talking about Agile projects and how they can benefit from automation and smart things that we've seen clients do, and maybe some cautions on some not so smart things we've seen clients do. I had this quote from Archimedes here. I think it's Archimedes. Give me a place to stand and a lever long enough and I will move the world. And certainly in Agile, the place where you stand is testing, and the lever is test automation. There's more and more reliance on putting all the right stuff in place from an automation point of view in Agile projects. But what we're also seeing is a lot of clients that are underutilizing or misutilizing the potential value there. So that's one of the things I want to try to clue you in on here. Because there are a lot of benefits to this. Failure costs can be significantly reduced with automation, especially in an Agile context, because there's so much of a focus on early removal of defects. When you remove defects early, via automation, a couple things happen. Fewer defects in later stages of testing means that those stages take less time, they're faster. And also, the automation that is introduced throughout the whole cycle is quicker than manual when done properly, and so schedules are accelerated that way as well. And by offloading some of the testing effort that is automatable to automated tools, that allows you to focus on expanding your test coverage in other ways. So there's really a lot of potential benefits here, again, if it's done properly. So let's look at what done properly would mean. If the slide will advance. Now, when I'm talking about automated testing here, I'm casting the net very broadly here. I'm talking about static tests that do not involve executing the software. I'm talking about white box or code-focused tests. I'm talking about black box tests. I'm talking about all of the above. Another thing it's important to keep in mind about automation is that you have a lot of options here. You can buy it, you can download open source, or you can build it. And all of those are options that you should try to keep in mind. Open source has gotten tremendously good over the last, say, 10 years, and a lot of that has been driven by the Agile prevalence of Agile, I guess you'd say. Now, it is also important to keep in mind that automated testing sounds like more than it actually is, because you're not actually automating all of the test process. What you're automating is the submission of inputs, the capture of results, and the comparison of those results against expected results, and the logging of that comparison. There's a lot of work that precedes that in terms of creating the automation, and there's also interpretation of the results that needs to happen afterwards. And those things are generally not automated. So you need to think of it as automating part of your test process, not automating the entire test process. Now, that said, it's still definitely worth doing if you do it right. But if you do it wrong, it will cause you a lot of trouble. I want to try to help you avoid some of those causes of trouble here as we go along. So let's start off with discussion of return on investment or business case. You might wonder, well, why start with this part? Well, the reason is that without a business case, without a return on investment, it's not a tool, it's a toy. And playing with toys can be lots of fun until management catches you doing it, and then they're going to make you stop. Now, that may seem kind of like flippant statement, but it's true. If you are not able to demonstrate a business case to management for what you're doing, then the odds that you're going to be able to continue to do it are going to go down. So what does a business case look like? Well, it depends. I'm going to focus on one way to justify the business case for automation here. But there could be other objectives that you might be serving. But assuming that the main objective that you're trying to serve is to reduce the overall cost of achieving a certain level of coverage, then what you need to do is look at three average costs. The average cost to develop tests, the average cost to execute the test, and the average cost to maintain the test, manual versus automated. So six figures falling into three different categories there. Okay, so the average cost to develop would include both the fixed and the per test costs that you would expend. Now, you see in this hypothetical example, and it is a purely hypothetical example here, that in this example, the average cost to develop an automated test case is $100, and the average cost to develop a manual test case is $10. So we're making a $90 return on investment in each automated test that we create. Now, how do we get that investment back? Well, the way we get that investment back is by running the tests. Okay. So in this, again, hypothetical example, it costs $50 to run the tests manually on average, and $25 to run a test, an automated test, again, on average across all of the tests. So we save $25 each time we run the tests. Now, that means that the fourth time we run the test, we get our $90 back plus 10% dividend, basically, which is good. But it leaves out the piece that often pops up and deflates the whole thing, which is maintenance. So if we look at the maintenance column there, the columns, you see that maintaining the manual tests costs $10 on average, is basically rewriting it. It generally wouldn't be that much, but in this hypothetical example, let's just assume that it is. While maintaining the automated tests is $30, so it costs you $20 each time. So as long as we don't have to maintain very frequently, notice that that's not going to be a big problem. But if we have to maintain every single time tests are executed, then that's going to reduce our return on investments to maybe $5 if we have to maintain the manual tests as well. Now, if it's $5, then it's going to take 18 executions, 18 cycles to get that $90 back. What we see with clients in some cases is that they have so many problems with maintainability that the ROI by this analysis actually becomes negative. So one of the things that I would encourage you to do is not only have this business case that you're tracking and you're able to analyze the ROI using it, but also look at a couple other things and graph these over time. The development, automated test development velocity and the automated test maintenance velocity. Because you want to watch very carefully for if it takes as long to maintain a test as to develop a new one, you definitely know you have test maintainability problems. So I'm actually going to do a one key idea session on those two metrics a little later, and I'll give you guys some examples of them when I do them, because they're very powerful metrics. But know your business case for sure. Okay, so continuous integration. Now, this is an idea that has been around for quite a while. I was doing some work over the weekend and came across something that I'd worked on in 2001, which was going in and building a continuous integration and test system for a client. And so this is back 2001. The technologies were a little different, but the main concept is the same. And then thinking about that, I remembered that I had actually worked on similar types of systems back in 1992. We had these automated build and test systems. So they're very well established. Pretty much all of our clients that I would say have successfully implemented Agile have some type of continuous integration framework, either using Jenkins or Hudson, but now there's other tools that are coming along as well, so it's a little more diverse. Generally speaking, unit testing is tapped into this, is part of this. Sometimes other types of testing are involved, which we'll talk more about, but unit testing seems to be the one that's most commonly present. Now, in addition to the unit testing capabilities that it creates, you also have the fact that it can reduce your likelihood of being delayed getting a build, or worse yet, getting a build that won't actually install. Properly set up, these continuous integration frameworks limit those risks. But we have seen situations where people set up the continuous integration frameworks to auto-deploy the builds into test environments whenever the builds are done. That naturally enough, that results in interruption of whatever testing is in progress at the time. And then you see that you end up losing a fair amount of time on people having to restart tests. So you want to make sure that this has been well coordinated. It's not just spraying builds out into the test environment whenever a build is finished. Now, by the way, I got a note here from Helen saying that that her audio had gone out, but since I'm only hearing it from her, I'm assuming that this is a glitch with her internet connection. As I've said numerous times before on this broadcast, we use GoToWebinar, as you know. GoToWebinar is a hub and spoke system. So if you lose your connection into the server, you'll lose audio and so forth. If I lose my connection into the server, everyone loses audio. So usually what I do is watch for a flood of comments about audio coming in, and when it's just one person, I know, okay, well, their connection dropped. When everybody starts doing it, then clearly there's a problem with my connection. I don't seem to have that. By the way, on that note, for various reasons, not just technical reasons, but also financial reasons and so forth. We decided we're going to be moving to Zoom, moving from GoToWebinar to Zoom on our subsequent webinars. You'll see that on the invites that start going out. We've had good reports about that. We've been using it for our virtual classes, and people are happy with it. So, so we'll be going to Zoom. Hopefully, you guys will like it too. Okay, static code analysis is also very, whoops, that wasn't supposed to happen. There we go. Static code analysis is also very common with our clients that are successfully doing continuous integration. We see a mix of both open source and commercial static tools being used in this situation. I couldn't say that I feel definitive one way or the other necessarily about that based on what I've heard from clients. Obviously, the commercial tools, cost money, and some of they can cost a lot of money. So the nice thing about the open source tools is that they're, free as always in budget. Now, one of the things that we see that's really underutilized is complexity analysis tools. So looking at things like cyclomatic complexity, for example, and other complexity metrics that can help you understand maintainability of the code. I think there's one called, I want to say Nmap, but that's not right. But there's a metric that's commonly associated with the Java check style tool, in addition to cyclomatic complexity, that is a useful one from a point of view of maintainability. Now, one of the things that you've got to, a couple things you've got to keep in mind about these static analysis tools. Obviously, they're looking directly at the code, and so, in order to understand what they're saying, you have to know how to read the code itself. Doesn't mean that you have to be able to write code. You don't have to be proficient as a programmer. It's like I often say that you don't have to write like Hemingway to read Hemingway's books. So it's just the same kind of thing here. You don't have to be some kind of genius programmer to be able to read code, but you do have to be literate in the programming languages that are being used. So that's one thing that I'd mentioned. The other thing is that the results have to be interpreted intelligently, whether we're talking about complexity analysis or we're talking about analysis of the code from a standards compliance point of view, maintainability point of view, security point of view, etc. These tools will flag things as possible problems. Doesn't mean they necessarily are a problem. So that is something to keep in mind, that you have to interpret the results, not just like have some sort of knee-jerk reaction to them and automatically try to fix them all. The other thing I would point out too about these static analysis tools is these should not be seen as a substitute for code reviews. Some of our clients do that, and they're like, yeah, we use the static tools, and so that's fine. We don't have to do code reviews. Well, certainly the static tools find things, and some of those things are things that will also come up in a code review. But the static tool can only look at what should be there, or what is there, excuse me, and it doesn't know what should be there. It doesn't know what's missing. It doesn't have any sort of context, project context or product context to interpret the results in. So use the static code analysis tools and then augment those with proper code reviews. If you say, well, I'm a professional tester and I don't participate in the code reviews, well, if you learn the programming language, then you can and you should. Now, as I said, unit testing is pretty common in these continuous integration frameworks. I'd say most of our clients have done that. And what we see most typically is that whole, what's sometimes referred to as the XUnit family of tools. So now, regrettably, there's a tool called XUnit. It's for .NET code, if I remember properly. So that's kind of confusing. But anyway, when I say X unit here, I'm referring to things like CPP unit, J unit, N unit, and so forth. And this is, typically these open source tools are the ones that are used. We've seen a few clients using commercial unit test tools, but that's really declined as the capability of these open source tools has expanded. Now, TDD, test-driven development. We do have some clients that say their developers are doing that, doing TDD. But what we find when we open the hood sometimes is that TDD can mean different things. Like in some cases, TDD means, yeah, we got really good unit tests, or yeah, we get 100% statement and branch coverage, and yeah, the developer has to submit their unit tests for review when they submit their code for a review, those kinds of things. That's fine, but what of course is actually meant by TDD is that the tests are written first, following a particular practice prior to the code being written. And, does it happen? Doesn't always happen. I had a client tell me, amusingly enough, that he was the director of testing in an organization, and he told his testers, look, do not use the phrase TDD or test-driven development around the developers, because apparently it became such a religious warfare kind of issue that he didn't want the testers getting scorched in the middle of it. Now, unit testing is all well and good, but have you tested everything? So we often see clients that are doing code coverage analysis using various tools. Again, open source and commercial are often used. Now, code coverage analysis is great as far as it goes, but again, it can only tell you whether you've tested what's there. It can't tell you whether what should be there is there, and it also can't tell you whether your tests were any good. And this is where this kind of comes back to the developers, because the developers who write their unit tests often don't have basic test design training and concepts. We're working with a client right now that we're running their developers. We're going to run their developers through both black box and white box test design so that they're sure that they understand these concepts, because what they find is that they are missing a lot of bugs. Now, it's also important to keep in mind, according to Capers-Jones's studies of various industry averages, which if you've read any of his books, you'll be familiar with this. He identifies unit testing as topping out at about 50% defect detection effectiveness. And this is compared to what we see when we measure independent test teams. Generally, will hit about 85% defect detection effectiveness. So there are various reasons for that limitation on unit testing. Some of it is just what can be covered in a unit test. I can't cover as many things as you can during a system test, though you can cover them at a finer grained level of detail. But some of it comes down to good test design. So if you're a tester and you're working in an environment where this stuff is going on, these automated unit tests are going on, but you don't have any participation or access to it, again, learn the basics of the programming languages that are in use, and how unit testing works, and how to design white box tests, and actually participate with the developers to try to boost the defect detection effectiveness of their unit tests. Okay, so feature verification testing. So this is a name that we came up with when I was leading the effort to write the ISTQB's Agile Testing Foundations syllabus, because it seemed like there were things that went under different names, but ultimately were about verifying that features did what the user stories and their acceptance criteria said they were supposed to do. So verification being checking that the system does what the specs say it's supposed to do, and features because it's focused on individual features. So you might, if you want to quibble with, sometimes a feature is seen as a much larger collection of functionality than the user story. You could call these user story verification tests if you prefer. Now, there are a number of tools that are used out there to support this kind of activity. You've got acceptance test-driven development and behavior-driven development. There's basically two families of tools that are used for that. We have not seen any commercial tools used. It's all open source. At one point, acceptance test-driven development appeared to be taking over, if you will, driving out behavior-driven development. But now that actually seems to be turning around, and we're seeing an awful lot of behavior-driven development. Whereas we had seen people moving away from BDD and switching to ATDD, it seems like the tools have matured a little bit on the BDD side, so there's a flow back there. But the basic concept ideally would be that testers, developers, and business stakeholders participate in this process. At the very least, you want the business stakeholders to review the test results, but it's better if they're involved in the test design for obvious reasons. It's also better if these tests are included into the continuous integration frameworks, though we don't always see that. Sometimes the obstacle there appears to be that the tools can run too slowly, and slow builds down. So what we've seen in some cases are this idea of tiered automation, where there's the first tier of automation that's run every time. It's generally going to be the static code analysis and the unit tests. Tier 2 may be BDD or ATDD types of tests. The tier 3 stuff would be automated tests at the system level, and the tier 2 stuff may be run overnight, and the tier 3 stuff run every other night or something along those lines. Obviously, that's kind of counter to the philosophy of fast feedback in Agile. So, you want to be a little careful about this kind of idea of tiering your automation. And speaking of automation at the system level, definitely graphical user interface test automation is what's frequently meant by that. There is a tremendous amount of Selenium out there. And by the way, people sometimes say, well, why do you say Selenium? Isn't it Selenium? Well, actually, if you go look up the pronunciation of it online, it is Selenium. So yes, I am saying it correctly. I'm going to stick with that, even though 95% of the time you hear somebody say this in a conference, and if they're talking about the test tool rather than the element, they're going to say Selenium or Selenium. So, well, I'll say Selenium. Anyway, so Selenium is very common out there, but there are some others that are floating around open source, and then there's the usual cadre of commercial tools that are out there, and they seem to kind of come and go, and that there's some that stick around. Now, this is a place where we see very frequent shipwrecks in a couple ways. One is, people forget the test automation pyramid. Now, if you're listening and going, like, what the heck is he talking about, test automation pyramid? You definitely need to look this up and do some reading on it, because basically it's talking about having most of your test automation at the lower levels of testing, like unit test level, and being very sparing in your automation at the system test level with the GUI tools. And the reason for that is twofold. One is maintainability tends to be lower, even with good keyword-driven or data-driven architectures. You're still going to have more maintainability issues with tests that work at graphical user interface than you would with unit tests. You're also going to find that it just takes longer to run the test, because they have to interact through the graphical user interface rather than interacting directly through APIs, and it's just faster. So there's a limit to how fast you're going to be able to run your tests if you're using the graphical user interface to do that. So take care. certainly do this. Keep in mind that this is a very complicated thing to do well, and there's a fair amount of upfront costs associated with engineering a proper framework, and if you don't do that right, then you are definitely going to have maintainability problems. So I would recommend having at least one person involved in this who's got 5 or more years of test automation experience, ideally automation at the graphical user interface level, and has some successes and failures under his or her belt. Because there's a lot of ways to screw this up, and if somebody's new to it and they manage to think of half of them, they're a genius. And it's those of us walking around, like I was making a joke about me being an old goat because of my 1994 Solaris developer conference, but there's you learn things when you're around for a while, and some of that is by making mistakes, and then to avoid those mistakes, and the mistakes are very, very common. Most of the time, if I'm talking to a client and they are sharing with me some tale of woe about how their automation just went completely off the rails and cost them a lot of money, it generally GUI test automation is at least part of the story. Not always, but quite often. All right. So performance testing. We see a lot of JMeter. Up until a few years ago, we would still run into OpenSTA, but I think OpenSTA is now defunct, I believe. So sadly, that's gone away. There may still be some people out there that are trying to use it, but it's the community's closed. Now there are commercial tools galore. Some of them quite expensive when you want to do large-scale load testing. Certainly, LoadRunner has that reputation of being extremely expensive if you need to do large-scale load simulations. There are, as I said, many other tools out there that may be more economical. The issue that you run into possibly will be that they don't have the kind of results reporting capabilities that you want. Now, we see less of an issue with maintenance and maintainability of performance tests, primarily because your test oracle is simpler, honestly. What I mean by that is we're not trying to sniff out subtle failures like, did it give me the exact right answer or something like that. I don't have to look at that. We just have to look at, was it fast enough? Was the throughput good enough? Was the resource utilization acceptable? So that is less of an issue. But that said, certainly see a number of clients that have managed to shoot themselves in the foot, as the saying goes, or shotgun themselves in the foot in some cases. They take people that don't really understand performance and performance engineering, performance testing, and give them a tool. The tools are quite whiz-bang, and they seem to be very easy to use. It's but it's misleading. It's like putting a super usable interface on a passenger jet. Okay, I mean, it may be really easy to understand, but unless you know what you're doing, somebody's going to get hurt, right? And that's generally what we see when underqualified people are involved in performance testing. So before you decide to try to utilize this, make sure that you know what you're doing, or you've got somebody in your team who knows what they're doing. A really good practice here with respect to performance testing is to do some performance modeling. Ideally, you'd be using a capacity modeling tool of some kind or another, but here again, there can be issues associated with expertise and cost, at the very least, what you should try to do is maybe use some spreadsheets to try to predict some factors like resource utilization, for example, and just sort of double check that your performance test results and your performance models are telling you the same thing, because it's really easy to construct a performance test that gives results that look reasonable but are wrong. And it's also really easy to construct a performance model that gives results that look reasonable and are wrong. But it's very unlikely that both of those things are going to be wrong in exactly the same way and double check each other, if you know what I mean. They're both going to give you wrong answers, but they're going to be two different wrong answers. So that's a good way of protecting yourself against that risk of, is my test telling me things I can believe. Okay, web services and service virtualization of various kinds. We have both commercial and open source tools. SOAP UI is probably the one that we hear about most frequently from freeware. There was a commercial and open source, or not open source, but freeware versions. And at one point, we heard that the commercial one was no more reliable than the free one, which kind of reduces the likelihood that people would pay for it. But I think that problem has now been mostly resolved. We do see some other tools out there, but haven't really heard about them as much. I think there's maybe an under awareness here. It may also be need. Certainly, though, you want to be aware of the potential to use these tools, because when they are useful, they are very useful. All right, dynamic analysis tools definitely have a place in certain contexts. I mean, if you're doing builds for specifically for testing, and you want to make sure that it's not going to get out into the big wide world, probably makes sense to use some dynamic analysis tools to do some special builds and analysis of those during your testing. Of course, you want to be careful. You never, whether we're talking about instrumentation to measure code coverage or instrumentation to look for memory leaks or what have you, you want to be very careful about inadvertently releasing to clients or customers code that actually has instrumentation in it. At the very least, it's going to slow things down. It can actually lead to different behaviors. I have had some clients tell me about that. This is an area that's definitely underutilized. We have a lot of software has reliability problems. In my phone, my Android phone here, I mean, pretty much every day I have to reboot this thing because I'm reasonably sure it's because of a memory leak and something. So I really wish that people would take memory leaks and other sources of reliability problems more seriously, because it's software reliability is bad. Okay. Now, test design tools. We do see a fair amount of use of pairwise testing tools, and PICT and AXE seem to be the two most common free tools. There are commercial tools out there, but I've never really seen the point of using the commercial tools, and PICT and AXE are perfectly good tools. We do hear about model-based testing, but we haven't seen a whole lot of clients actually using it yet, though we have built model-based test systems for some of our clients. If you go out on our website and do a search in the articles page for It's called Quality Goes Bananas, which is it feels a silly name, but you'll get it once you read the article. It talks about how we built this model-based testing tool using open source components. There are other test design tools out there. I've seen some of the commercial test design tools, and a lot of times the way those work is that they require the requirements to be in a particular format, and they go in and parse the requirements and generate tests out of them. But what that really means is that you have to write requirements that look like tests and have the level of detail in them that you would have in tests. And so it's just sort of shunting the problem from one side of the life cycle to another. And, you know, are you really going to be able to get your business analysts and your product owners and other business stakeholders to agree to write your tests for you? It seems like a questionable thing. We do not see a lot of these tools out there other than, as I said, the picked and axed for pairwise and some, you know, very initial modest levels of model-based testing. And scripting. Scripting is great. Very useful from a test point of view. We have Ruby, of course. We've got Python. Python is, last time I checked, the fastest growing and most widely used programming language in the world, amazingly enough. There's still TCL and TK out there, believe it or not. They fit a certain niche when you need to create very lightweight testing frameworks to, for example, mobile devices, limited memory situations. So one of the things that we've run into is this what I call Tower of Babel problem with scripting, where people have their own favorite scripting languages and they refuse to use anything but their own favorite scripting language. And then that creates problems with sharing and so forth. Now, scripting is simpler than programming, but it's very similar to programming. So ideally, people that are doing it are programmers. But it is possible as a tester to pick up a book and teach yourself how to do Python or Ruby or some of the Unix shell scripts and so forth. It's really not. Scripts are really easy to get started with, and you grow your experience over time. Another thing that's good is if you are working in Unix, then you've got some part of a script, you're not sure how exactly it's going to work, you just try it out on the command line and see how it works. Now, you do have to be careful. It's like any other kind of programming. There's potential maintainability problems. So take care, especially if you're going to build something that's large, complex, sophisticated. Well, certainly that can be done. I've done it myself. But you do want to take care that you're addressing the maintainability issue, because lack of maintainability will kill you on automation. All right. Conclusions. Do this right, do the automation right, and you will get solid benefits. We've had a lot of clients that have problems for sure, but we've also seen plenty of clients that do this right and do get very solid benefits, solid return on investment. Definitely none of the cautions that I've given should be taken as, hey, don't do automation. It's all about make sure you're doing it right. Make sure you think about both commercial options and open source options. We have clients that will say, well, I'm only going open source because I'm never going to spend any money on tools. And I've got clients that say, we're only going commercial. We can't have any tools that don't have commercial support. And I think they cut themselves off from a lot of good options. So, I would recommend that you consider both. And I believe I've done a webinar in the past, which you can go check out, about how to do smart tool selection. If you haven't listened to that, you definitely should, because choice of the wrong tool, not understanding the requirements for the tool and so forth, these are all things that are very common causes of trouble. Now, on open source, you know, definitely be careful that you keep in mind that free software is kind of like free puppy. you know, it's it's free puppy in the sense of you stop on the side of the road and somebody has a box full of puppies and they give you the puppy, but that doesn't mean that that person's going to show up every time that puppy needs to go to the vet and write you a check for the puppy's vet bill. Or when the puppy gets sick in the middle of the night and there's a big mess in your bedroom, is that person, you can't just call that person up and say, "Hey, come clean up my bedroom. Your puppy got sick." Um, so remember that you're going to be investing time and money in that tool, and you know that's something to consider. And on the other side of the ledger, um, the commercial tool vendors, because they have to convince you to spend money on their tool, often make some very interesting tests about their purebred puppy, right? So you get the mongrel open source free puppy on the side of the road, and you've got the purebred puppy that you're buying from the vendor, and that vendor will tell you about the bloodline and this dog is sired by this master hunting dog or something like that. You hear these kinds of things, obviously not about hunting dogs, but about other kinds of things like, oh yeah, anybody can use this tool to automate tests, and the tests maintain themselves, and they're scriptless, and all sorts of other fun stuff. You'll get your money back in the first 15 weeks. So yeah, be very skeptical about what the tool vendors say. Now, should you build your own tools? Well, there was a time when this made a lot more sense, and certainly I've built plenty of automation solutions myself. But given the amount of open source that's available now, I would say, my first option would be to look at open source. And even if I had to integrate multiple open source tools together, that's probably better than building something from the ground up. But in some cases, you do have to build things from the ground up. And so if you are in that sort of situation, make sure that you've got a properly qualified test toolsmith there who can help you do that. You may need to have a test toolsmith around anyway, just because of this whole idea of integration code and glue code and so forth. When you're trying to get complex automated tools to work together, in some cases they don't want to work together, and you have to make them work together through use of this kind of integration code. So that may be something that you do need to do. All right, so I'm going to put the advertisement up and get ready for the Q&A, and I'm going to take any questions that you might have. Before we do that, a quick little verbal advertisement here. We do have a team of international consultants that deliver customized training, consulting, and expert services to companies just like yours. So if you're looking to improve your test and quality assurance practices and you feel like you receive valuable information from these free webinars, please do help us to continue to provide them by making RBCS your preferred software testing vendor, any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. You can contact us, info@rbcs-us.com. And you probably noticed that we're changing up our approach to webinars, giving you even more types of interactions. Me talking to other people. We're going to have other people on, have had other people on, and so forth. So we're hoping that you see that we're bringing even more value to you through these webinars, and again, hope that leads you to say, hey, if I need to purchase testing services, I'm definitely going to talk to RBCS. All right, so what do we got in the way of questions here? That Helen's comment earlier about audio not working, and then somebody came and said, no, it works fine, and Helen came back and said, yeah, it's fine again. So it's typical Citrix audio dropout glitch due to connectivity. Tom says, if we follow the test automation pyramid, where the largest portion of automated tests are related to the unit test, won't ROI take a big hit since unit tests typically require a lot of maintenance? I don't know why your unit tests would be requiring a lot of maintenance, Tom. That's funny. That's unusual. The only reason that a unit test should require maintenance is if the code that it's testing has changed, in which case that would be done by the developer, and the developer would update the unit test at the time they updated their code. But why would the code be requiring so many changes? Usually what we see with clients is that the hit to ROI associated with maintenance happens at the system level, not at the unit level. So I don't know what's going on there, Tom. It sounds like you've got some sort of dysfunction in the programming / development side of the equation that maybe somebody should take a look at. Certainly that's something that we can do for you if you'd like, is come in and do an assessment of your automation and give you a write-up on that. We did a couple of those in the last 6 months, so be happy to come in and look at it. It sounds like just something's broke. Donald says, our big automation issue is platforms. Virtual machines, script distribution, results aggregation, and we have no sysops, DevOps people. Any recommendations on tools for building and scaling virtual machines? I'll say again what I always say when asked this question about specific tools. We don't do tool recommendations without actually coming in and studying the client's specific situation. So I would be very hesitant to say anything definitive here. I'd want to really get a sense of what the hitch is here, and what your options would be. Again, certainly something that we do, but tool. One of the things that I've seen happen quite frequently is that the major contributing factor to test automation failure is selection of the wrong tool. So I'm very hesitant to say, oh, well, just do this or do that. It might not work out real well. And I don't want you to come back and say, you gave me bad advice. Okay, let's see. We got anything else? Any other questions here? That was either very, very clear or was so confusing that only 2 people could formulate questions. Well, very good. Here we got one more from Catherine. My company is starting to look at using Tosca, model-based and risk-based, for test automation, which will include GUI testing. Are you familiar with Tosca? I am familiar with Tosca in the sense that I have bumped into them at conferences. And since they're at conferences, they must have at least enough money to pay to have a booth and send people there and so forth. So I assume that they have customers, and I would assume that some of those customers are happy customers. I just don't know any of their customers. None of Tosca's customers are current RBCS clients, so I can't give you any sort of experience reports like here's what we're hearing from our clients about Tosca. So it's neither good nor bad, right? This is a problem. It's a fairly common problem when you have new tools that come along, or just whole new areas. Like this happened with mobile too, where there was just tremendous growth in the mobile tool space, mobile testing tool space, but you know, not a lot of long-term client success stories available. So I would say do what you should always do, which is, very carefully identify your requirements and follow the tool selection process. There's one that's, if you look at the ISTQB Advanced Test Manager syllabus, there's a pretty good description of how to select a tool there. You definitely want to do a proof of concept and make sure that it will solve your problem. The proof of concept should be for your code, not their canned demo. I always say canned demos don't prove anything, other than if the canned demo fails. Don't walk away from the vendor, run, because how incompetent do you have to be to have something that you put together to demonstrate the usefulness of your tool and it doesn't work? But just because a canned demo works, it doesn't tell you anything about solving your problem. So do a proof of concept, do pilot projects, do a phase rollout after the pilot projects if they succeed. Just go slow here. Now, I know my friend and colleague Bob Binder would disagree with me when I characterize model-based testing as kind of a new thing, but I guess my difference with Bob on that is just that it's not, for whatever reason, we don't see as much use of it by our clients as maybe it deserves. So what that tells me is just go slow, Catherine, and take your time. All right, Chad has a question. Any advice on reporting and metrics on test automation we're trying to accomplish in Sprint progressive automation? Now, in Sprint progressive automation, I'm going to assume that what you mean by that, Chad, is not just regression testing, but actually developing your tests and executing them in the same iteration in which the code that corresponds to those tests is being created. Excuse me. So, assuming that I am correctly interpreting your question, Chad says correct and without manual tests. Okay. All right. Well, let me address this in two parts. So I'm going to address the easy part first. You said without manual tests. If that means that one of the things you're trying to accomplish here is 100% automation of your tests, that's not good, because what that means in practice is that any test that cannot be successfully automated won't be run. And that doesn't, just because a test can't be successfully automated doesn't mean that it is not mitigating a risk that you need to mitigate. So I would say, yeah, that's definitely a metric not to have, 100% automation. Every time I see that, it's, either something bad is happening or it's about to happen. Now, in terms of metrics for test automation, assuming what we're looking at is get the automated tests that we do need to have up and running in the same sprint in which the code was developed. Well, I mentioned having test development velocity and also test maintenance velocity. I still think those are very useful metrics, but those don't go to the problem that you're talking about or the objective that you're talking about, Chad, because your objective here is about the usefulness of the tests, right? At the point of then how long before they're available. So in addition to the maintenance velocity and the development velocity, just as general metrics for your specific objective, one that was hard to say, what I would suggest is looking at exactly that gap that I was just talking about of like what is the number of days between when a the code that corresponds to a particular user story is first checked in for build, and when the test is ready to test it. All right, now that number could be negative. You could actually, the test could conceivably have been created before the code was checked in, and that's fine. Maybe you're calculating an average, that kind of gives you some credit, right? Another way to look at it is the time between when the code was checked in and included in a build and when the automated test first executed against that code. Obviously, that number cannot be less than 0, right? I mean, that'd be the code got checked in and it got built, and then bam, it immediately got subjected to an automated test, so there was 0 lag time, right? So basically, it's a lag time metric that you're looking at. What's the lag time between when the code hits the test environment and when the test is ready to test the code? And you'd want to look at that lag time on a user story by user story basis, I would guess, and push that down as close to 0 as you can get it. And now an average, I say average. Average might not be the right way of calculating that, because you may have some outliers, code that's not easily automatable, and you decide to wait on it for a long time, and then 3 months later, some automated piece of code or an automated test drops in for this piece of code that's been out for 3 months, and bam, that just blows up your average. So maybe more like you want to look at a median or something like that. There are some ways probably of constructing that metric so that it doesn't, it's not easily distorted by weirdness. Anyway, play around with it. Play around with the metric a little bit, before you start reporting it out. But that's definitely something that's measurable. All right, Catherine said thank you for the answer. You're quite welcome, Catherine. Good. So it's a little after 2 o'clock. I'm trying to keep these a little more concise now. People seem to have somewhat shorter attention spans. So I'm trying to keep them short. So we'll close this one down. Do remember we run these once a month in one format or another. We got the 1 key ideas and 2 points of view at 2 and those sort of things, and we're mixing it up. So go out to our website, rbcs-us.com, to sign up. Sign up for our free newsletter, and you get valuable discounts on consulting and training services, along with a regular newsletter that gives you some news about what we are up to lately. You can follow us at the various social media coordinates that are shown here. Do get signed up for our podcasts if sometimes you miss these webinars, because these do get posted in podcasts, and that's generally a good way of listening to them. Some of our webinars, of course, have metrics and tables and graphics and so forth that make them a little harder in a podcast format. But one like this is very easy to listen to, and you can listen to it doing anything. So somebody who's a real podcast addict and they're a tester as well, you might point them towards that. So we got lots of free resources. There's a YouTube channel as well out there. You can take advantage of that. This webinar will be posted out there. So we offer all these resources, free resources, as a service to the software testing community, because at RBCS we are a not just for profit company. But don't forget, we also need to keep the lights on. So as long as you think that these webinars are something that should keep happening, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Concludes the webinar today. Thank you all for attending, and look forward to seeing you on future webinars.